All right, we have a sample problem here. A simple pendulum oscillates with a period of 5 seconds. So period, capital T, or uppercase T, is equal to 5 seconds. And they want to know how many complete oscillations. So that's cycles or rotations. That's what we're looking for. And we know that has no units. That's the unknown. How many oscillations does it make in a time of 15 seconds? So that's a lowercase t, and that's 15 seconds. All right, so we go back to our equation where period equals time per cycles. And we have to isolate n. So to do that, since t is divided by n, we need to multiply both sides by n. The n's on this side will cancel, and we're left with n times period equals lowercase t. We still don't have n isolated yet because n is multiplied by period, uppercase t. So to get n by itself, we can divide both sides by period. The periods on this side cancel, and we're left with n equals time over period. Interesting, we could have said period equals time over n and literally just flip-flopped these two, and we would get the same result. N equals t over period. Right? These two are the same. So that's a little shortcut trick that you can use rather than going through all the proper math in the center of the screen here. At any rate, we're left with n equals t time over period. So the time we got was 15 seconds, and the period was 5. So the number of cycles, 15 divided by 5, would be 3. So that's the answer to the problem, and we're done. But suppose we went a step further. We said, okay, that's the number of cycles. We know the period. What's the frequency? Well, frequency is equal to n over t. And n, we just figured out, was 3. And the time would be 15. If you do the math, you'll come up with 0.2 hertz. So that's, whoops. So that would be the frequency. Easy enough. It's kind of interesting to see that we could have used another approach. We know that frequency is equal to 1 over the period. They gave us the period. It was 5. 1 over 5, 0.2 hertz. So our answer is the same for frequency regardless of which approach we use. Hope this helps.